Imagine, a robot comes into your kitchen, takes eggs out of the refrigerator, heats up a pan, makes breakfast and cleans up after itself, all from a single voice command. Sounds like science fiction? Elon Musk claims this will happen this very year, but between the promise and reality lies a gap that Tesla hasn't crossed yet. And right now, the company is making the riskiest bet in the history of robotics. Tesla Optimus Gen 3 is supposed to launch this summer. According to Musk, this will be the first truly production-ready version of the robot. Not a prototype, not a demo model, but a machine ready for real work. 5 key upgrades: the ability to learn on its own, and the capability to perform more than 100 different tasks a day. But before we talk about Gen 3, we need to understand where Tesla stands right now, and why the path to this goal turned out to be much harder than it initially seemed. What Tesla is showing to the public today is still version 2.5. Musk personally clarified this on his account. We haven't shown Optimus Gen 3 yet, it's magnificent. Version 2.5 is already noticeably different from its predecessor. The body has been redesigned, smoother lines and closed joints, almost no exposed cables. The robot has become visually closer to a consumer product rather than an engineering test bench. In addition, version 2.5 features integration with xAI's Grok voice assistant. The robot can answer questions out loud. The pauses are still noticeable and the dialogue still sounds a bit awkward, but this is already a fundamentally different level of interaction compared to what came before. Gen 3, according to Musk, will take the next step: a more natural gait, a new onboard computer based on the AI5 chip, hands with capabilities closer to human ones, and a design optimized for mass production. Musk talks about producing around 1 million units per year, and he considers Gen 3 to be the version that makes this a reality. But this raises the main question that most discussions avoid. What does ready for real work actually mean? Look at the humanoid robots currently being actively showcased around the world. They run, they do flips, they dance, they box. The videos are impressive, but once the initial excitement fades, one simple question remains: can this robot wash a plate? A robot capable of running across a room might very well crush a neck when trying to pick it up. A robot performing acrobatic tricks probably has no idea how to open a refrigerator, find the right product, turn on the stove, put a pan on it, adjust the temperature, and wipe down the surface after cooking. This is exactly what Optimus is aimed at. Musk has repeatedly said Gen 3 wasn't created for a show. It was created for boring, monotonous, physically hard or dangerous work. The kind of work people don't want to do, don't have time to do, or shouldn't do. But for this to become reality, Tesla has to solve one of the toughest problems in robotics: teaching a machine to operate in a world built exclusively for humans. Optimus needs to understand the space around it, know where the refrigerator handle is, tell an egg apart from a tomato, understand which part of a pan is safe to grab, calculate grip strength, sense temperature, and know when the food is ready. For us, all of this is automatic. For a robot, it's a complex chain of decisions where every mistake has consequences. Squeeze the egg a little too hard, it cracks. Loosen the grip, it slips out. Turn the wrist at the wrong angle, dinner ends up on the floor. That's exactly why cooking food isn't just a flashy demonstration. It's proof that the robot is starting to truly interact with the physical world. And this is where hands take center stage. Tesla is developing hands with 22 degrees of freedom for Gen 3. This number matters. It enables movements that standard industrial grippers can't achieve. But degrees of freedom are only part of the challenge. The real difficulty lies in the actuators, the mechanical muscles that drive every joint and every finger. Musk acknowledges, creating a truly dexterous robotic hand is already extremely hard. But manufacturing hundreds of thousands of such hands with consistent quality is a task of an entirely different order. This is exactly where the line runs between a prototype and a real product. Tesla is developing custom actuators for different parts of the body. Hips require high torque to maintain balance. Shoulders need smooth, natural movement. Wrists need flexibility and a wide range of motion. Fingers need extreme precision. Using one type of actuator for the entire body would result in a robot that's heavier, slower, and more expensive. Optimizing each unit for its specific task is a bet on real functionality, not on impressive specs in a presentation. Now about the brain. Even the most advanced hands are useless without a computing system fast enough. That's why the switch to the AI 5 chip could be the most important upgrade in Gen 3. The robot can't fully depend on the cloud. If Optimus is carrying a tray of food and a child suddenly appears in front of it, it can't wait for a response from a server. If it's holding a glass, it can send a request over the network to figure out how much force to apply. These decisions have to be made instantly inside the robot itself. A self-driving car has to perceive the road and react to it. A humanoid robot does the same thing, but it also physically interacts with objects, people, and an unpredictable environment. This is a fundamentally different level of computational load. If AI-5 truly can process large amounts of data locally at low power consumption, Optimus will become faster, safer, and significantly more autonomous. Now, about how the robot will learn. Tesla is building a system called Optimus Academy. The point isn't to manually program every possible situation. The point is to create a self-learning loop. The robot works, makes mistakes. Data about those mistakes goes into the system, the software improves, and the update gets pushed out to the entire fleet of machines. And here's the key point. When one robot masters a new skill, that skill becomes available to all the others. One Optimus learns to move parts on a factory floor, another learns to serve food, a third learns to clean a house. All of this experience gets accumulated into a single system. Musk talks about a fleet of 10, 20 or even 30,000 robots simultaneously training and sharing knowledge. The more robots working, the faster the whole system learns. But Tesla doesn't exist in a vacuum. Boston Dynamics has released Atlas, an industrial robot about 190 cm tall, weighing around 90 kg, with 56 degrees of freedom and roughly 4 hours of runtime. It's a powerful machine for factories and warehouses, but not for a home kitchen. On the other side, there's pressure from the Chinese market. Unitree offers a compact G1 robot about 130 cm tall for around $13,500, and the R1 model goes for about $4,900. Musk himself has acknowledged that these prices are changing how the market perceives things. If Optimus Gen 3 launches at an inflated price, promises of future cost reductions won't convince buyers as easily as they used to. Tesla has a clear commercialization logic. Optimus doesn't need to be able to do everything at once. It just needs to perform a handful of repetitive, economically valuable tasks and do them well. Every successful task completion adds to the database. The database improves the system. The system rolls out new skills to the entire fleet. This isn't just about selling robots, it's about building a continuously learning network, where every machine gets smarter from the experience of all the others. So, are you ready for a robot to make you breakfast? Would you buy an Optimus if Tesla started selling them right now? Let us know in the comments. If this video caught your attention, hit like and subscribe to the channel. New episodes are only for those who stick with us.